talking about the indefinite integrals, which we have done over and over and over again at this point, so we're still using those. It's not going away. We're just going to look at some more problems like that, some that we've done before, some maybe a little more tricky. And then the one new piece that we're looking at is net change. So we already know what an indefinite integral is. We know an integral means an antiderivative. So we're basically finding something so that when you take the derivative, you get that inside function. We know the difference between definite and indefinite, so this section is just kind of stating that. Definite is when you have numbers to plug in. Indefinite, you do not. So the indefinite is when we need the plus c on the end. So if I asked you to work this problem, so we're doing an indefinite integral, which just means the antiderivative. Because we don't have numbers, we know we have to put the plus c at the end here. So what is the antiderivative of 10x to the fourth?
2x to the fifth.
You have to add 1 to your power, so that means you have to multiply by 1/5 or divide by 5, so we get 2x to the fifth minus 2 secant squared x. So coefficients just stay. What has a derivative of secant squared?
Secant tangent?
Tangent.
Oh, just
You were thinking of the derivative of secant.
Okay,
Yes, secant
yeah.
tangent.
So you
So we can't just make this like secant cubed, because when we do the derivative of that, we'd have to do chain rule, so we had to ask ourselves what has a derivative of secant squared? And that was our tangent. And that's our answer. Nothing else we can do there. Let's look at this one. Can we do the antiderivative of a quotient? No, we do not have a quotient rule in reverse. So we have to think about how we might rewrite this. We have a cosine and a sine squared. Sine squared just means sine times sine. Okay, I don't have a product rule in reverse either, so this isn't good enough yet. What is cosine over sine? What is 1 over sine? Okay, this is still a product, so I can't just do the antiderivative of each one, but do we know anything that has a derivative equal to cosecant cotangent?
Negative
Okay, so derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. So if I want a positive cosecant cotangent, and what does this need on the end?
plus c.
So sometimes we have to rewrite it first before we're going to be able to find that antiderivative. Next one. You guys can do this one. So the antiderivative of x cubed is 1/4 x to the fourth minus the antiderivative of 6x would be 3x squared, and 0 to 3. So if you plug in a 3 to the fourth is 81. 3 squared is 9. Plug in a 0, all of that is 0, so you get 81 over 4 minus 27, which is what? Negative 27 over That one okay? This one. Alright, so antiderivative of 2x cubed. So it would be, that would go to next the 4, so you need a 1/4 in front. 2 times 1/4 is 1/2. Minus antiderivative of 6x, so it would have to go to a 1/2 x squared, so 1/2 times 6 is 3. This is like 3 times 1 over x squared plus 1. Didn't I do a problem yesterday involving the antiderivative of 1 over x squared plus 1? One of your homework questions, remember I worked it out for you? It was a special form.
No. No.
What are you doing there with 3?
Go back to the antiderivative of the 1 over x.
Tangent.
That was the
Oh,
tangent
yeah.
inverse formula. Alright, so if we plug these in, 2 to the 4th is 16 times 1/2 is 8. 2 squared is 4 times 3 is 12. Plus 3 tangent inverse of 2. Minus, if we put in a 0, okay, so this gives me a -4 plus 3 tangent inverse of 2 minus tangent inverse of 0. It's like asking when tangent equals 0. And so I'm sure you guys remember tangent of 0, so it'd be like square root of 0 over 4. Tangent of 0 is 0. So this actually turns into a 0. And that would be our final answer. Again, that was a formula I never made you memorize, so probably not going to put it on a test. But I thought I'd take the opportunity to throw in a couple examples involving that. All right. Number 5. Something that we kind of struggled with on the last test. You cannot just do an antiderivative of a quotient. So what am I going to have to do here? Simplify this first. So it's like putting each piece over your denominator. T squared times the square root of t. That's like a t squared times a t to the 1/2. So if we simplify this, 2t squared over t squared is just 2. Plus, those will cancel, so t to the 1/2. Minus 1 over t squared would be t to the -2 power. So now this is set up where we can do the antiderivative. So the antiderivative of 2 is 2t plus, okay, t to the 1/2. So if you add 1 to the power, that's 3/2. So you need 2/3 in front. -2, if you add 1 is -1, so we need a -1 in front. So if we plug in a 9, 2 times 9 is 18, plus 2/3 times 9 to the 3/2, or the square root of 9 cubed, plus 9 to the -1, or 1 over 9. Plug in a 1. Square root of 9 is 3. 2 to the 3rd is 27. Times 2/3, so 27 divided by 3 is 9, times 2 is 18. Over here, let's see, 2 plus 1 is 3, so we'd have a -3 minus 2/3. So 36 minus 3. This would be like negative 6 over 9. So 1 over 9 minus 6 over 9 is negative 5 over 9. Do you guys all understand how I'm working these out by hand? Just trying to help you practice that skill. We struggle with that a bit. So this would be the same thing as 32 and 4/9. Or you could write that as an improper fraction or a decimal. Not the prettiest problem ever, but we can do it without using a calculator. Okay. The second piece of this is kind of the newer piece, and it's really just talking about what an integral means. So we're just looking at the meaning of some of these things. First thing I do want to talk about, net change is the overall amount of change. It is really looking at the antiderivative, that final answer. So if we get a negative 5, that's saying it decreased 5 over that interval. Or the area was like a negative 5 because it was below the axis. If you get a positive 8, that's like saying it was above the x-axis, so it increased by 8 over that interval. So net change is just talking about how something changes over time. We can use that idea to kind of interpret what these intervals mean when they are applied to real situations. So if we are looking at volume, V is volume, then we know a derivative is the rate of change. So if the V is the volume, V prime is how the volume changes over time. Then if I integrate it over a specific interval, that will give me the actual amount of change in the water. So if I integrated, let's say we had a tank of water and water was leaking out, and we integrated that rate of change. You know, we measured how fast the water was coming out, we did the antiderivative, and we got negative 10. That means in that time interval, 10 gallons of water leaked out. Okay, so it tells us how the amount changed over time. If we're looking at a chemical reaction, if C of T is the concentration, then the derivative is the rate of change in the concentration. If you do the integral, that goes back to the concentration, so it's just telling you how the concentration changed over time, how the amount of the chemical changed over time. So we know a derivative is the rate of change, the antiderivative goes back to that amount. If you're looking at mass, then the derivative of that is talking about linear density. So the antiderivative takes it back to mass. So it's looking at how the mass changed over a set amount of time. Another situation, we see lots of derivatives when we're talking about how a population changes. So you have if you have a population function, the derivative is the rate of change in the population. Antiderivative in this particular interval would tell you how the actual population changed during that time frame. Cost and marginal cost. This is another application we've used a lot. We know that if we have a cost function, the derivative is marginal cost. So if you integrate that, you get the actual change in cost over that period of time. Another one, we talk about position, velocity, acceleration, those kinds of things. So if you integrate a velocity function, you're going back to position. So it tells you how your actual position changed over that set amount of time. The other thing I want to talk about is the difference between displacement and distance. If I took a ball, okay, and I rolled it to the end of the room and it bounced and came back. If I asked you for displacement, that's how its position changed from when it started. If it went all the way there and came back, then it's in the same position. So my displacement is 0. It is where it started. But if I ask you how about the distance traveled, is distance negative? So it traveled all the way there and all the way back. So my distance would be a set number, right? So we have to be careful when we do antiderivatives. It takes care of like things below the axis are negative, and so when you do the antiderivative, it's giving you displacement. It's subtracting off the negatives. But if I asked you about the distance, you would have to find all three of these and make them positive and add them together. So we're going to look at some questions where I might ask you for the total change, in which case we have to look at what happens when we get to those negatives. So let's look at some examples. We have a particle is moving across the line, along a line. This is my velocity function. I want to look at the difference between displacement and distance traveled. Okay? Displacement is just how the position changed from where it began. So that is just my antiderivative. So we are just going to integrate. We're going between 1 and 4 of t squared minus t minus 6. So antiderivative of t squared is 1/3 t cubed minus 1/2 t squared minus 6t from 1 to 4. So if we plug in a 4, 4 squared is 16 times 1/2 is 8. Again, a 1. Okay. So we get 64 over 3 minus 1 over 3 would be 63 over 3, or 21. Negative 32 plus 6 is negative 26 plus 1/2. So negative 5, so that's negative 10 over 2 plus 1 over 2 is a negative 9 over 2. So my displacement turned out to be negative. What does that mean? Bless you. This tells me we're looking at how a particle moved. So it tells me the particle ended 4.5 meters behind where it started. Now, does that mean it only moved 4.5 meters total? No, it could have gone forward and came back more than once, for all I know. But its final position is 4.5 meters behind the starting point. That's what displacement is. Distance traveled. So the distance traveled, it's kind of similar. It's still an antiderivative, but distance can't be negative. So you would have to integrate the absolute value of our function. Now we have done the antiderivative of absolute value functions before. We have to first figure out what makes them equal 0. So that factors into t minus 3, t plus 2. So this equals 0 at positive 3 and negative 2. Is negative 2 in my interval? No, so I don't even have to worry about that one. So we're going to have to integrate from 1 to 3 and from 3 to 4. Between 1 and 3, would this be positive or negative? So if you plugged a 2 in here, 4 minus 2 minus 6, that is negative. So the absolute value does the opposite. Can I just distribute a negative through all of those? Negative t squared plus t plus 6. Okay, if you're between 3 and 4, if you plug in a 4, 16 minus 4 minus 6 is positive, so the absolute value doesn't change it. So now we're ready to do the antiderivative. Negative 1/3 t cubed plus 1/2 t squared plus 6t. This one will be the same thing, just opposite signs. So let's evaluate this. We put it in a 3, we get negative 27 over 3, so negative 9. So 9 over 2, 13. So then work this out for me, guys. Let's see what we get.
Yes, can you give me a calculator? Didn't try to do. We're working on doing it. Oh.
Over 6. So you notice the total distance traveled cannot be negative because distance is always positive. It will turn out to be higher than displacement most of the time. You could get the exact same answer for displacement and distance if your object never moved backwards. So if it only goes forward, your displacement is the same as distance traveled. So do you guys understand the difference between displacement and distance travel? Let's see. I don't think I'm going to do the last example. So your assignment, I'm going to modify slightly. I want you to do, I'm not going to do 1 and 3. So I want you to do 5 through 11 odd.